That we're going to do today, we are going to use this paper that was provided to you, specifically looking at these identities and then knowing both our primary and our secondary trig functions. And so if you could do me a favor and go on in your homework and find where it says fundamental identities number 2. Fundamental identities number 2. So we are going to start off with number 1, where I have a little more space to show my work. And we're going to start by distributing. You are going to work through this with me. So I have the sine of x times the cosecant of x, bless you. A positive times a negative is a negative, and I have sine squared x. Now what I recognize is that a sine squared, I can isolate sine squared on these identities. So to get sine squared by itself, I need to move cosine squared to the opposite side. So sine squared here, if I come off the side here, if I came way up here and said sine squared x plus cosine squared x equals 1. This is the identity, and I want to isolate for sine squared. So I would subtract cosine squared x. Make sure you're sitting with somebody. Thank you. Cosine squared x. So sine squared x is equal to 1 minus cosine squared x. I'm going to take this and replace it where I see sine squared. So I have sine of x times cosecant of x minus, and now in this region, I'm going to write 1 minus cosine squared. Next, I'm going to distribute the negative sign to both, and I end up with sine of x times cosecant of x. A negative times a 1 is a negative 1. A negative times a negative is a positive. I know, looking at this paper, that cosecant is the same as 1 over sine. So I'm going to rewrite the cosecant as the sine of x times 1 over the sine of x. Cosecant is 1 over the sine minus 1 plus cosine squared x. Now when I multiply, I get sine of x over sine of x. And sine of x over sine of x, when you have the same value divided by itself, you get 1. So this region right here equals 1. 1 minus 1 plus cosine squared x. The 1s are going to be eliminated, and I'm left with cosine squared x. That is number 1. Let's take a look at number 2. Please make sure this is in your packet. Make sure this is in your packet right now. We're moving on to number 2. Number 2, you could ask Leslie if you're confused. Packets were passed out last week. We're on after today, we'll be halfway done with this unit. Okay, what can I do here? Well, I know that cosine squared, again, in the exact same way here, if I want to isolate cosine squared, so if I come over here, and if I had sine squared x plus cosine squared x equals 1, if I want to isolate cosine squared, I'd move sine squared to the opposite side, 1 minus sine squared x. Make sure you're writing every step down that I am. So now on top, I'm going to replace that with 1 minus the sine squared x over 1 minus sine of x. In the past, I've seen students who think they're able to just cancel these out. We're going to take a second, go off to the side, and I want you to recognize, let's start off with something very basic that you learned freshman year. If I wrote 25x squared minus 4, hopefully you would recognize that is 5x plus 2 and 5x minus 2. Difference of squares. Okay, now what if I change it up and did 1 minus 9x squared? Same concept, the variables in back. So 1 plus 3x and 1 minus 3x. We're doing that same concept here on the top. So what I'm able to do on top is I'm able to rewrite this as 2 different quantities, leaving 1 minus the sine of x in the bottom. So I can take this and expand this to 1 plus the sine of x and 1 minus the sine of x. If I asked you to take this and to expand this or to FOIL this, you would end up with the fronts multiplied to give you 1 times 1. The outsides would give you a negative sine of x. The inside would give you a positive sine of x. And when you multiply the last, you'd have minus sine squared x. And that's how you end up with 1 minus sine squared x. So I just took this and it's rewritten in expanded form as 1 plus the sine of x times 1 minus the sine of x. So the obvious that we can see here is these two are going to be simplified to 1, and I'm left with 1 minus the sine of x. Okay, we are moving on now to, 1 plus the sine of x is what I'm left with on top, We're moving on to number 3. Number 3. Okay, when you look at number 3, recognize that I'm able to see 1 plus tangent squared, 1 plus tangent squared. If you have not walked up to my desk or you did not grab this on Friday, let's all look here at the identities, and I'm looking at 1 plus tangent squared. Okay, how can I rewrite this? Oh, it's already there. 1 plus tangent squared is on the left-hand side, and that's equal to secant squared. So I'm going to replace this portion. I'm going to replace this portion with secant squared. So I have cosine of x times secant squared x. Now I know that secant is the reciprocal of cosine, so I can rewrite secant squared as 1 over the cosine squared. Make sure you're keeping all up with these notes. 1 over the cosine squared. And now when I multiply across, I'm left with cosine of x on top. On the bottom, I have cosine squared. I'm just going to expand that to cosine and cosine. Cosine squared is cosine times cosine. Remember, these don't just cancel out. They're going to reduce down to 1, and I'm left with 1 over the cosine of x. Not wrong. It's not wrong. But what is 1 over the cosine of x equivalent to? 1 over the cosine of x is equivalent to the secant. So this is equal to the secant of x. Let's look now at number 4, moving on to number 4. When I look at the left and I look at the right, I notice they both have a cotangent squared. So I'm going to factor out a cotangent squared out of these quantities. So cotangent squared x. And now what goes inside? Cotangent squared x times what equals cotangent squared x? Cotangent squared times what equals a negative cotangent squared cosine squared? And let's make sure I did this right. If we distribute, we get cotangent squared x. If we distribute, we get negative cotangent squared cosine squared. All right, so again, I see this, and I recognize I can look right up above. This comes from the most common trig identity. Sine squared plus cosine squared equals 1. So it comes from right here. See how I've already isolated sine squared? 1 minus cosine squared. 1 minus cosine squared is equal to sine squared. I can replace this portion with sine squared. Cotangent squared x times sine squared x. What is the cotangent? Yes, it's reciprocal of sine, but if we look back over here, notice cotangent is cosine over sine. Cotangent is cosine over sine. So cotangent squared is cosine squared x over sine squared x. On the right, I have sine squared x over 1. I'm able to reduce, these turn into 1, and now I have cosine squared x over 1, which is simply the same as cosine squared x. Let's look now at number 5. Let's look now at number 5. Okay, I'm going to press pause, and I'm going to give you 30 seconds to see if you see how you could rewrite this. All right, so you ready? When we expand this out, we're going to write it twice. So on your paper, let's write this down twice. We have sine of x plus cosine of x twice times the sine of x plus the cosine of x. And now I'm going to use the FOILing method you learned in 8th and 9th grade. Multiply the fronts to get sine of x squared. Multiply the inside to get cosine of x times the sine of x. Multiply the outsides to again get cosine of x times sine of x, and multiply last to get cosine squared x. We're only adding 4 different quantities. Notice that whether you write cosine of x and then maybe you wrote sine of x, as long as you have one cosine and one sine, I can combine these 2 terms. So there's a total of 2 groups of cosine of x, sine of x. And then what I notice about this is that I'm adding. So what is sine squared x plus cosine squared x? Let's go back to the most common identity. Sine squared x plus cosine squared x is 1. This portion equals 1. So I have 1 plus 2 times the cosine of x, sine of x. And that is my final answer. Let's look at number 6. Let's look at number 6. Number 6, unfortunately, although it looks similar, I do not have a common denominator. And so I'm going to use the butterfly method. As a reminder, I'm taking 1 times 1 minus cosine of x. So 1 times this is simply 1 minus the cosine of x. And then I'm adding it to 1 times 1 plus the cosine of x. On the bottom, I'm going to multiply the denominator. So 1 plus cosine of x and 1 minus the cosine of x. All right, let's just do some simplifying here. On top, I have 1 plus 1 is 2, and a negative cosine and a positive cosine are additive inverses. They're going to cancel out. Now on the bottom, I'm going to FOIL this out, and I'm going to do it off here, off to the side where I have a little more room. Multiplying the fronts to get 1. Multiplying the outsides to get a negative cosine of x, multiplying the insides to get a positive cosine of x, and multiplying the last to get a negative cosine squared x. Okay, negative cosine and positive cosine are going to cancel, and I have 1 minus the cosine squared x. Let's go back to the identities. Which one of these 3 identities could I rewrite to be left with 1 minus cosine squared x? Talk to your partner. Is it the first, the second, or the third? It should be the first. So if I move the cosine to the opposite side, it has to be subtracted. So sine squared equals 1 minus cosine squared. So I can replace this portion with sine squared. So 2 over the sine squared x. And although that's not wrong, having sine in the denominator is equivalent to what? Having sine in the denominator is equivalent to the cosecant. So I have 2 times the, cosecant squared x.